Hi again. We're going to look at misleading graphs today. This is a really important topic. This is something you're going to come across a lot in your life when you're watching the news, reading the newspaper. People don't read newspapers anymore. Looking on the internet, whatever. You're going to see all these graphs, and unfortunately, a lot of them are misleading. So what does it mean for a graph to be misleading? It means that it misrepresents the data. It gives you data, but the data is presented in a way that kind of doesn't match up with reality. So the result is that an incorrect conclusion may be derived from it. So you're going to look at a graph, and if it's misleading, you may look at it and say, oh, look at that. People in Canada live longer. And then when you actually look at the data, you're like, wait a minute. No, that's not true. People in Canada, it's exactly the same, or we actually live less than some nations. So I don't know. That was just a weird example I made up. So we're going to look at 4 basic ways. What's with that extra spacing in there? Weird. 4 basic ways how graphs can present misleading impressions of data. Now, there's definitely more than 4. In fact, if you go to Wikipedia, they actually have a whole section on misleading graphs. And right in this area here, they've got 13 different ones listed right there. So the 4 that I'm listing encompasses quite a few of these, but not all 13. One, for example, that I didn't use, which I actually like, is excessive usage. So what they mean by that is sometimes a graph just makes things more complicated than if you just said it in words. There's lots of ways to make misleading graphs. Here are the 4 I would say most common. Okay, number 1. This is the most common way, in my opinion. The number 1 way to make a graph misleading is it's called displaced axis. So what that means is the numbers on the axis do not start at 0. Right? If you look at this graph here, it starts at 50. And oh, wouldn't you know it, this one starts at 50 as well. Anyway, it could start anywhere and it would be misleading. So take a look at this graph here. Now, I don't even know what they're comparing here. So let's say this is 3 classes of marks. So this is Waj's class, this is Yi's class, and this is Lam's class. Oh, look at that. My class did the best. Wow, who would have thought? Anyway, when you look at these marks right here, so we're going to pretend this is percent here. When you look at this right now, what are the 2 conclusions you'd probably make? Well, one conclusion you make is that Yi and Lam, their kids get around the same score. And that's actually true. The other impression you make is that Waj's kids get higher marks, and that's also true, but you might be a little more specific than that and say, wow, if you look at these bars, Waj's class got like more than 2 times, it looks like 3 times as good as these guys. That is not true. My students, although definitely better, did not get 3 times as good. In fact, if you were to draw this properly, so it starts at 0, and here's 50, whoops, 50, and here's 100 here, what did my class get? 62.5. So my class would be around here. And the other 2 classes got how much? 50, just under 55. So they would be up around there. Did my class do better? Yes. Is it as pronounced as this? No. All right, let's take this one. It's exactly the same idea. This time they've got titles and everything. Percent who agreed with court. So I guess the court in the United States made some decision. And then they took a look at the Democrats and the Republicans, the 2 main parties in the United States, plus independent voters, people who don't associate themselves as being Democrats or Republicans. And gosh, it's almost exactly the same. I should have done a different example. Because look, these 2 have exactly the same, and yes, that's true. The Democrats is the highest. It looks like they're way more accepting of the court decision than these 2 groups, but really, they're at 54, and the Democrats are at 62. These numbers are almost identical to what we did. I should have looked at this a little bit more carefully. So I would say that's the most common way that graphs are made misleading. Remember, if you are going to start at a number other than 0, you should be putting this broken line to show people, hey, careful when you read this graph. I'm not starting at 0. I don't think you should ever do it with bar graphs. The one type of graph you could get away with sometimes doing the broken axis is the line graph. Even that is up for debate sometimes. Okay, second way to misrepresent data is to have an irregular or inappropriate scale. So what that means is the spacing between numbers on an axis is not consistent, or it's excessive. So I guess one thing that could be true, although gosh, it'd be so rare to see this. This is like a grade 8 student making graphs. Sometimes they'll do this. They'll go like 10, and then they'll go 20, and then they'll go 21, and then 23, and then 30. You can't do that, right? If you're going up by 10 and 10, you got to keep going up by 10, 10, 10. It's not fair to do it this way. So that would be like a really somewhat rare but possible way of messing this up. How about this one? Looks pretty good. Starts at 0, goes up by 10, 10, 10, 10. 2019, 20, 21, 22, 23. Looks perfect. What's not great about this? I would say what's not great about this is you have all this space up here just being wasted. Now, I know you might say, well, big deal. Who cares, Mr. Wadge, if you just waste space? But the reason this is misleading is because it makes it look like there's really not that much change. But if you were to do another graph, let's say it went from 0 and then 5, 10, 15, like that, and redid this, the first one is at about, what, 7? The next one is above 10. Next one looks to be right around 10. Then it goes up a little bit higher than this one, and then down a little bit from there. This gives you a different impression. This is making it seem like it actually is increasing more dramatically than the one here shows. Now it's a bit of a trade-off here, because if you did too much of this, if you went up like 1, 2, 3, 4, 5, you're going to end up with a graph that looks like something like this, and that's probably misleading as well. So it is a bit of an art here to make a graph that's not misleading in any way. Okay, this one is ridiculous. So I know it's a bit hard to understand what they're talking about, but they're looking at two companies, I suppose, and they want to know who's got a bigger part of the share, bigger part of the market. So which one's more popular? Well, this brown one is more popular, right? I mean, look, it's way up here. So the Intel one looks like the superior product, except down here. I think we can all agree that during this time, 2000, what is this? First quarter of 2013, second quarter of 2013. So in 2013, we can all agree that black was more popular, right? AMD was more popular? No, that's wrong. What? How could that be? Well, let's see if we can figure out how much this point represents and how much this point represents. It's actually tricky. Do you know why? Because there's two scales on this. On the left-hand side, they have a scale, and it goes with the AMD, with the black one. On the right-hand side, they have a scale, and it goes with the Intel, with the brown one. So when we're reading this is confusing, but when I'm reading this one, the black one, which is AMD, I should be reading this using this scale. So this is 3%. And it definitely looks higher than this one, right? Wrong. Because when I'm reading this one, I'm using the Intel scale. The brown line's the Intel, and that's way over here. I go over here and I get approximately 97%. What the? How could you possibly draw this one higher when it's only 3% and this one's 97%? This is a horribly misleading graph. Real graph, by the way. I didn't make these up. Okay, the third way. This is why I hate pictographs. They're so bad at doing this. The third way to misrepresent data is to have an exaggerated use of area or volume. And this is where parts of the graph are drawn too large or too small. So for example, in this one here, you've got this kind of pseudo pictograph, but you've put it on a chart here. It's kind of like subbing in for a bar graphs. Rather than draw bars, let's make it cool and draw the balls because we're talking about sporting events. No, it just makes it look like this basketball is so much bigger than the baseball, so much bigger than the puck. Even the puck looks way bigger than the baseball. If you were to draw this with bar graphs, hockey would go up to here, baseball would go up to here, pretty well exactly the same, and basketball would go up to here. Is it higher? Yeah, it is higher, but it doesn't look as excessive as it does when you draw these big balls like this. Okay, how about this one? Well, first of all, by making it 3D, it really exaggerates the things up front. It really draws your eyes to this purple one and this green one as well. So, when you put it 3D, even though it looks attractive, you're really losing the perspective on these back things here. Talk to Mr. Sinclair about this. The other thing is, why have they put this one piece kind of semi-detached from the rest of the pie? It definitely, again, draws your eye to this one. It makes item C seem like it's much more important than the other ones. Does it look good? Yeah, this looks cool. Awesome. Is it effective? No, don't do that. It misleads people. All right, the fourth one I'll talk about is when you use the wrong graph. Okay, so here's two examples. The first one's a real thing, the NFL, National Football League, billion-dollar company. So what they're looking at is how many first round draft picks have come from different universities in the United States. And what they found is, I mean, just look at the graph. Who's done the best? Well, look at SC. That's USC, University of Southern California. Look at how well they've done. Look at how big that piece of the pie is compared to all the other ones. I mean, what's the next biggest? The Ohio State, the Ohio State, and it looks like USC is about twice as big. Wow, so much better. Wait a minute. The actual number here is 69 for the USC and 64 for Ohio State. They're practically the same. You can't do this. What type of graph should have been used instead? They should have used a bar graph. Okay, this last one, I'll admit I made this one. So we've got students' test marks. And take a look. Oh, wow, I feel really good. The students' test marks are going up. It started below 50, and now it's way up in the 80s somewhere. Wow, that's great. What a good teacher. Wait a minute. What's wrong with this? This is not expressing some one student's test over time. This is just different students' marks. This does not make sense to put a line graph. A line graph is used when things change over time. So what should this actually have looked like? You should have had one bar for Byron, who got around 50%. One bar for Samantha, who got around here. One bar for Sherry. One bar for Jason. And one bar for Roger. And by the way, I'm going to do something wrong here. Whoops. What did I do wrong there? It's not fair to make one bar, oh yeah, make one bar wider and maybe make it a different color than everyone else and everything. No, you can't do that either. That's going back to this one. We're exaggerating one part of the graph. So anyway, bar graph here, not a line graph. All right, now I have a whole bunch of examples. I'm going to whip through some of them quickly with you. I just can't believe some of them. So look at this. What's wrong with this one? Well, they've made the trash can way too big here. They should be using the same size trash can if they're going to do these cheesy pictogram models. Otherwise, just make one bar, the same width bar, and the same width bar. That doesn't exaggerate it as much. Next one. Oh, hate the pictograph. Okay, when you look at this, it looks like there's a few more registered cars than trucks, right? Look at this bar is just a little bit more than that one. Wait a minute. Each one of these little cars is 9 million actual cars. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18 and a half. 18 and a half times 9 is, this is 166.5 million. 1, 2, 3, 4, 5, 6, 7. This is only 63 million. I mean, this is almost 3 times as much, and yet the bar makes it seem like it's just a little more horrible. No good to have one bar that's way thicker than the other ones. What's wrong with this one? Okay, math scores. Wow, look at how well overachievers did compared to these other schools. Like, look at Dallsville, horrible. But wait a minute. Dallsville's mark was 301. Overachievers was 305. They're practically the same mark. What happened here? They didn't start at 0. If you were to draw this correctly, it would look like this. They basically all got the same mark. Next. That looks okay. It starts at 0, 2, 4, 6, 8, 10, 12. That's good. Wow, what's wrong? Well, what's wrong is they cherry-picked which years to use. 92, 94, so they're going up by 2 years. Whoa, what happened in 96? They go 95, then 2 again, 2 again. You can't change. This is the same as changing the scale on this side. You also can't change the scale on that side. Here's what it would actually look like. Well, if you included all the years, it actually looks like this. So here it looks like hurricanes are increasing. Oh my gosh, we're all going to die of hurricanes. When you look at this one, you're like, yeah, they just go up some years, down some years. Yeah, it's up a little bit, but it'll probably end up coming back down. So very misleading, this one. Okay, what's wrong with this? Well, you got the one 3D one that makes way bigger than the other ones. If you were to draw it correctly, it looks like this. It's actually the same as this one here, even though it looks a lot more prominent. Next, oh, I love this one. Drinking ages across Canada. Look at, our drinking age is so much higher than Alberta. I mean, look at how much higher that bar is than that bar. Wait a minute, it's only 1 year different. How did they make it look so extreme? They started at 17 and then went up by 0.6. How ridiculous is this when you're talking about years? Someone actually made this graph? I mean, you should be ashamed of yourself. Again, don't make, does it look cool? Oh, so cool. But it's making this green one looks so much more prominent, where I think all these colors are all exactly the same. Same thing here. This makes entertainment seem so much more a piece of the pie than the other ones. Problem with this one, we don't start at 0, and look at this, goes up by, I guess, 1,000, 1,000, 1,000, and suddenly then this is 1,000. You can't make this equal 1,000, that amount, and then make this equal 1,000, which is like 3 times as much. That's not fair either. They did it again up here. The 1,000 span is much bigger than the 1,000 span here. No good. Unemployment rate, Clinton and Bush, two U.S. presidents. Wow, Clinton's not doing very well. Look at all the unemployment when he... Wait a minute. The difference, 5.2 and 5. This rounds to 5.2 as well. It's basically the same. Started at 5.175 and went up by 0.005. Ridiculous. Oh, topical one. Biggest COVID-19 worries. Getting it, the family getting it, and the economy. What's wrong with this one? It adds up to more than 100% here. That can't be possible. They should have used a bar graph. Obviously, some people picked more than one option. They should have picked a bar graph. One would be at 62%, one would be a little bit higher, and one would be a little lower, and that would make sense. This doesn't make sense. Job loss by quarter. Oh wow, job losses are really going up. Wait a minute. December 07, then it goes to September 08. That's about 10 months difference from there to there. Then it goes to March 09. That's about 6 months to there. And then it goes to June 10th. That's about 15 months to there. They're just cherry picking the ones to make it seem extreme. In fact, maybe it goes something like this. Down, up. Sorry. Maybe it goes like that. And job loss goes up and down and up and down. But by picking all the high points, they make it look like it's just increasing and increasing and increasing. Oh, love this one. Gun deaths in Florida. Well, this is encouraging. Gun deaths look like they're going down here. Once they made this stand your ground law where you're allowed, I think, to shoot people coming onto your property or something. Gun deaths actually went down. You know what they've done? This is very devious. I can't believe anyone would ever do this. But look at Florida Department of Law Enforcement. They started at 0, and as you go down, it goes 200, 400, 600, 800. Do you know what that means? This graph is actually upside down. It should start above 800, and it should end at around 721. I don't know, I'm just approximate. It looks like this. So once they enacted the stand your ground law, it's actually shot up. And I think a little down in the last few years. Okay, yeah, no comment on that one. You either get it or you don't. And same with this one. There's misleading nonsense all over this one. I mean, look at 24, 25, 5. This is just foolishness. All right, everyone, look out for those misleading graphs. They're out there. You don't want to be fooled.